Okay, so a couple of examples of why this stuff is important, and there are numerous examples, and hopefully we'll be able to explore a lot of those examples in the course, but that depends on whether people do their homework and do it conscientiously. Okay, so, here's a graph of profit versus selling price. What this graph shows us is if we don't put our selling price high enough, we don't make a profit. Because, of course, if we sell whatever we're selling for too little, we won't get enough money to make up for what it costs us to produce it. Okay, advertising, all that stuff. Okay. And then, of course, if we set the price too high, then we make zero profit. Of course, you know, the x-axis is where y equals zero, and that's something we really need to make sure we understand. But anyhow, if we set the profit too high, again, and set our price too high, then our profit is again zero. Okay. Well, where do we want to sell the selling price? How would you draw a line on the graph that tells us where to set the selling price? Well, I'm not going to ask you to do that, although it wouldn't be bad to stop and see, you know, get your own opinion about what line I might mean. But the line I mean is this line. This is a selling price. The maximum profit. And it should be obvious that that's your maximum profit there. Also, this line, y is the maximum profit. And this is nothing but an upside down scatter graph. Now, what numbers go with this? What are the coordinates of HK? What are the coordinates of Y and X? What are the coordinates of X on these two vertical lines? What are the coordinates of Y on these two horizontal lines? Well, all that comes out with some analysis. It's not really very simple analysis, but it's not that hard either. Okay, so and I'll just say that there are two linear functions. If you know how the demand for this thing varies with the selling price, well, what you know is that the higher you sell it, the fewer people are going to buy it. So your graph of number bought versus selling price looks like this. But then the more you sell it for, the more you make for each one. So what you make for each one has a graph that looks like this, and you multiply those two graphs together essentially, and you get this graph. And or a graph similar to this, and then maybe you subtract what it takes to manufacture the thing to finally get a profit. Okay, well, you don't need to know that, but you have to understand, okay, if you're going into business, and a lot of people are, it's very helpful to understand this model in as much detail as you can. You don't just go to ChatGPT and say, hey, what should I sell my selling price? You want to understand, and it's not hard to understand. Okay. Now there's deeper analysis that you might use software to do. More refined analysis. This is only a model. This is a model. Profit versus selling price. I think it's a good idea to start your model out with being able to construct a squaring function. Now, if you want to construct a squaring function in this box and you knew what various things were, you can subdivide it in the usual way with vertical lines. You'd probably do horizontal lines from the lower edge to the upper edge because you do it toward the edge that has a red dot on it. And the red dot goes that we call the vertex of the parabola. You don't have to remember that, but it's not that hard to kind of get the idea of what I'm talking about. Okay, now over here, we have what was supposed to be an exponential graph, but I really kind of screwed it up. So I'm gonna just quickly do a construction to make it better looking exponential graph. So that one really doesn't have the right type of curvature. This point should have been a lot higher. This point would go about here. This point should have been somewhat higher, and the curve really should have looked like this. Okay, that's what your word is model. This is good exponential modeling green. And this is a pretty bad exponential. And that's one reason you don't want to just sit down and sketch something you think looks about right. Now, we can use this model to make predictions. We don't need to have a computer. We don't need to have a calculator. If we've got the right numbers, if we know what number goes here and here and what number's up here and down here at 0, then we can adjust this model to our expectations. And we can do it on a piece of paper. And we don't have to rely on a bunch of numbers that come out of a spreadsheet or an artificial intelligence or calculator, okay? And we can always calculate those numbers. Okay? So this could model one of two things, and many other things as well. Population or principle. Population, this could be the population of guppies in a tank. I love to use that example. I won't go into the history of why I think guppies in a tank are very interesting, but you've got a big aquarium tank and a bunch of little guppies, about 3/4 of an inch long. Okay, put a couple of them in the tank, pretty soon you're going to get more guppies. And then you're going to get even more guppies and even more guppies. The more guppies you got, the more new guppies you get. Until the tank gets pretty full and they don't have room and they're competing for food and they're eating each other and all kinds of terrible things happen. And you don't have the exponential population growth, but it starts out exponential, or the ideal model is it starts out exponential. Every ecosystem, that tank being a tiny ecosystem, is going to have its variations and conditions are going to be different. They might not even be consistent. But your immediate expectation is you're going to follow an exponential model of the population. So this allows you to determine, if you know how long it takes it to double once, then you know how long it takes it to double another time. Turns out that these lines here, construction lines, are doubling lines. And I'm getting a message on my computer. Wanting to make some kind of thing on my hard drive. It's going to crash Zoom, so I'm not going to let it happen. Okay. So I was in the middle of the sentence. I kind of interrupted myself. In any case, this is a model. Gives an idea what's going to happen. And oh yeah, what I was saying is doubling time. If you remember, if you know how these lines are subdivided, each of these being twice as close to the lower line as the one before, then you know that whatever time it takes your population to double is going to be the same. Between each one of these pair of lines, the population is going to double. So you know how long it takes to double, you can write out your model, and it's going to be valid as long as the conditions allow a constant doubling time, which means that the rate at which the population increases is proportional to the population itself. The more guppies you got, the more guppies you get. Okay. Also works for money. For instance, if you put money into an account at, let's say, 4% annual interest, okay? Then turns out that money is going to double about every 18 years or a little less. So after 18 years, this is the amount of money you have when you start. After 18 years, this is what you have. After 36 years, after 54 years, if you're young, that's retirement time, your money will have quadrupled. Doesn't mean its value will quadruple, because you also are working against inflation. So, but if inflation is under 4%, which it is right now, and it's a nice change from what it's been the last few years. Then your money is gonna increase in value, and that's why you invest money, okay? That's why you put away money for retirement. Okay. And again, just by this graph, you can kind of estimate what's gonna happen. If you think that the money's gonna grow at 2%, well, let's say you think your money's gonna beat inflation at 2%, it's still pretty good. It means after 36 years, the value will have increased. So, you know, if you're 25 years old and by age 61, you'll have twice as much value as you put into it. Now, we don't know what's gonna happen to the economy, we don't know what's gonna happen to the world. But you look at historical trends and hope that they continue in a way we can continue to predict them, and then these functions become quite valuable. Well, that's just a couple of important applications of business. Try to maximize profit with populations or money. You try to predict what's going to happen to your numbers. Okay, now the details, there's not much more detail to it than what we see early in the course, except there's algebra. So if I want to know when has my money tripled, it doubles here, it doubles here. Well, it's going to triple sometime between here and here. It's going to triple less than halfway between here and here, or more than halfway between here. Just exactly when it's going to triple. Or when is our population going to triple, so we know how much food to buy. Ordering food years in advance. Okay. And of course, what price should we charge to maximize our profit? And this is a simple model. You can tweak this model a little bit. It gets a little more complicated. But the analysis you learn in pre-calculus and calculus allows you to deal with those models in a meaningful way where you understand what's going on, and when you understand what this tweak is likely to do. You want to understand that here. Okay. You don't want to just ask some AI what's going to happen. You won't have any intuition. You won't know whether it's telling you right or wrong. You don't know how to balance the information it's giving you with your understanding, because you don't have enough understanding to balance it. Okay, well, just a couple of examples. There are numerous examples, far too numerous to cover in the course, but we'll cover some fundamental models. And of course, it's important to be able to figure out what Y is for a given X. If you do X, here's your Y, or what X corresponds to given Y. You want to say you want your profit to be here, because for some reason in a deeper analysis, you think that's going to be safer as a prediction. Then you have two values of X that would give you that profit. And you can do the algebra and solve the equation. Okay. And in this course, we very quickly get to where we can figure out what the equation is. You can solve this equation. Now, if you know what the function is, you can decide on an X and predict the Y. That's easy. Okay. You don't need to use much algebra to do that. You just have to do the arithmetic and or let the calculator do the arithmetic. If you want to find a given Y, you want to know when the population reaches this level. Well, that means you got to find this point on the graph to find out what X is. If you don't understand that, you will soon. You can read that off the graph and get a pretty good idea. Probably good enough in the real world to be useful. One way or another, you get a feel for it. And then if you have to get a precise answer, you just do the algebra. Okay. You don't know the algebra to do this one, you should know the algebra to do this one, and if you don't, you will soon in the course. Okay, so again, those are just two examples and some reasons why the stuff that we're doing is going to be really useful to you if you're in a situation where you need to make these models. And in your curriculum, if you're in pre-calculus, it's likely that you will.